Hello and welcome to anyone tuning in to video 2 of our Vectors and Motions unit for IB Physics. In this video, we'll be going over 4 questions that help apply the knowledge we know to solve exam-style questions. Now, without any further ado, let us begin with our first question. Question 1 introduces us with a river 60 meters wide and a boat that travels at 4 meters per second. The river also has a current that flows at a constant 3 meters per second, and the question asks us how long it takes the boat to cross the river in a straight line. Since we know our boat travels at a rate of 4 meters per second, with the river having a current of 3 meters per second, if the boat reaches the direct opposite of our starting point, the net horizontal force of our two vectors must be 0. Hence, we can simply use our Pythagorean theorem to solve the remaining vertical force, which is the speed at which our boat crosses the river. And since x equals 2.6 meters per second, our answer to question 1 will be around 6 seconds. Question 2 gives us a system with two masses, both 5 kilograms. One mass is on a slope angled 25 degrees from the ground, while the other is hanging from a rope that connects to the other mass. The question asks us to solve the acceleration and tension in the system, where acceleration is down the slope. Therefore, we can make two equations that equal tension to solve for acceleration. By doing so, we can see that we'll have an acceleration of negative 2.83. Note that a negative acceleration is possible since it represents the mass moving up the slope as to down the slope. Then, we can substitute our acceleration into a previous equation and solve for tension. In this problem, tension is around 35 newtons. Question 3 is a two-part question where there is a block on a slope of 30 degrees with the weight and coefficient of dynamic friction given. For part A, we will calculate the static frictional force. The static frictional force is simply another way to say the force resisting the block from moving, which is also the force of the block acting along the slope. Therefore, static coefficient of friction is 1.5 newtons. Part B gives us the angle at which the block starts moving. With that angle, we can now find the static coefficient of friction, using the equation Fmax is equal to the coefficient of static friction times the normal reaction force, which is also in the formula booklet. Fmax is the maximum force friction can apply before the block starts moving. We can find this using our frictional force equation from part A, but replace the angle with 42 degrees. As a result, the static coefficient of friction is 0.9. For the second half of part B, we will find the net force on the block sliding down the slope. To do this, we will use the dynamic coefficient of friction given to us in the problem and the total force acting to make the block slide down. First, use a sine equation to find the force that makes the block slide at 42 degrees. Then, simply subtract the frictional force. Once this is done, we'll be left with a net force of around 0.7 newtons acting on the block. Question 4 focuses on a man in an elevator which is moving upwards at a speed of 3 meters per second. Here, we are given the time taken for the elevator to come to rest and the man's weight in order to solve for the reaction force and net force while the elevator is decelerating. For this particular question, there are two ways in which we can solve for the reaction force acting on the man. Firstly, there's the method in which we draw a force diagram to visualize the forces acting on the man. Put simply, there will be two forces acting on the man in this equation, his weight and the acceleration force from the elevator. By using the equation of weight plus acceleration force, we can find the normal reaction force. The second way to find the normal reaction force for this problem is by finding the sum of accelerations to find the net acceleration. When we do this, there will be no need for us to calculate two different forces, but rather use a single equation to find the force acting on the man, which is also equal to the normal reaction force. As seen in the two methods, both will come out to a normal reaction force of 595 newtons. Once we've done this, we just need to find the net force acting on the man. To do this, we can calculate the forces acting upwards and downwards to get a final net force. The upwards force will include the normal reaction force of the weight plus the force of acceleration, since acceleration was negative. The final equation will be 700 minus 805, leaving us with a total of negative 105 newtons. And there we have it, 4 exam-style questions on vectors in motion. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.